Hello guys, so welcome to the second video of Lab 2, Experiment 2. In that video, now we're gonna apply this, practical parameter sweep, let's say. Again, we're gonna apply it in multisim, but this will give you an idea, very good idea about what you're gonna do exactly in a lab, in a practical lab setup to get a parameter sweep. Okay, so basically we're gonna follow again the manual. I will share it with you as well. So here is the setup of our experiment. We need an AC source of this needs because we need to change V and check the current each time. But this will be done by the oscilloscope, not us now. Okay, but still we need something that is changing. Okay, so we need an AC source. It can be sinusoidal, can be whatever, but something is changing. We need the value that we're gonna verify Ohm's law across it, which is R1. So the slope should be 1000 or 1 kilo. And we need this small resistor equal to 1 ohm so that its voltage will be equivalent to the current that flows in R1. And the oscilloscope, this is oscilloscope in multisim. Okay, so let's place our components right now. So we just place R here. I'll tell you, where is it? Yes, it's in here. Just one click, don't double click it. Here is the first resistor, second resistor. Then we need a power source. We click B, power sources. Yeah, okay, let's do it. It's AC source because I double click. Don't double click, just one click. But anyway, it was an AC source. This is the one that we want, okay? We need also ground, and this is the ground, and that's it, so close afterwards. Okay, we need to change the name of this source to Vn because I don't like this naming of V1, the default naming, and the value to be 10 volt RMS. RMS, for home of you that didn't, study before AC circuit, RMS is just a unit of measure, So basically Vmax, the maximum of the sine wave, will be the value of RMS multiplied by square root of 2. So for example, here it's 10 volt RMS. So the maximum of the sine wave, the peak, will be 10 times square root of 2. Square root of 2 is around 1.4. So we expect V input to be 14 volt, okay, maximum. We need to make this as R1 as vertical as well R2. Get this around the center, align these together and connect now R1 to the positive terminal of the input, R1 and R2, then R2 with the negative terminal of the input, and finally the ground to that terminal. We need the oscilloscope. The oscilloscope are on the rightmost panel. Just hover over each symbol until you get it. Maybe number 4, yes, number 4 exactly. Okay, as you see here, the oscilloscope has 2 channels, A and B. Channel A will be our voltage. Channel B would be I'm sorry, and here is the second terminal of it. So the two terminals now of R1 are connected to channel A. So channel A will measure or will show the voltage across R1. And the channel B should measure the current or the voltage of R2, and R2 is equal to 1 ohm. Oh, we didn't change, so we change it first. Change it to 1 ohm. Sorry about that. Now the voltage of R2 will be on channel B because the channel B now 2 terminals are the 2 terminals of R2, and R2 is equal to 1 ohm. So the voltage that is shown by channel B on the oscilloscope will be also the current of R2, and the current of R2 is exactly the current of R1. One may say no, because here is the current goes, and at that point it should branch. No, it will not branch because again, the oscilloscope is a voltmeter, and the voltmeter has theoretically infinite input resistance. So the current in that branch and that branch are all zeros. Okay, now we are ready. Let's maybe move it a little bit to the center, yes. And now we can run. So we run from here. Nothing happened. Yeah, because to show the voltage, so the signals, we should double click on the oscilloscope. Now we make the setup here. So I have here the setup for you guys. So first, you see that the two signals are red. There is a signal that is shown and really clear. The other one is also red, and it's very small, so the scale is not expand a lot. So first, before we deal with other things, let's close this and change this the color of one of the signals to blue, because now they are both red. So it's harder to discriminate, we can say. So just right click, and yeah, because it's running, so we should stop running first. And right click again here, segment color, and choose blue. Why blue? Because I like blue. That's a complete different story. So, and let's run again. Double click here and see, guys. Now the background color are bad, so let's reverse from here to white. This button here reverses between white and black. Now one of the signals is blue, which is channel A. Channel A. The other is red, and you see the other one is very small. So to make it clear and visible to us, let's change its scale. So here are the settings that you should do. Some of them are already there, like this one and this one. So we need to make the scale of channel B is 20 millivolt per division. So let's decrease this. It's currently 5 volt, not milli. 20 millivolt per division. Now it's 20. So you see, guys, it's become clearer now. We can leave this as 10 or make it 5 or 10, whatever. Okay. Now we change this to single, and we have it here now. This one is not important, but you can, okay, but that's better now. Now let's learn how to measure the peak voltage, or how to measure AC voltage or a peak voltage on oscilloscope. So basically, this is required here for this table. Okay, this table here. So to measure the peak, we use these markers. So you see, guys, so this marker, when it moves and it have a little circle, okay, that moves along one of the signals. So it's now basically running across channel A signal, which is the blue one. And whenever it stops, it will give you the reading. So look at this reading here, and when we move the marker, look, it always changing. So channel A is 14.031. One may say also channel B changing. When I move this marker, channel B changing. You see this guy is also changing, because the marker will point to one of the signals, but it will measure everything that the marker crosses. So the marker also crosses through channel B, which is red. So it also gives you its reading. Now, if we take these two measures, remember, channel A is the voltage across R1. Channel B is the voltage across R2, and at the same time, the current, because R2 is equal to 1. And we know if we divide the voltage of R1 by its current, it should give us the value of R1. If we divide this by this is 14, around 14, divided by 14 milli. 14 will go with 14, and we will have 1 milli in the denominator. It can go to numerator, and we invert the sign of the 10, so it will be 10 to the power of 3, which is 1000. That's the resistor, basically. Okay, that's good. Now we are on the, you can say we are on the correct way. You take these two peaks, the peak of channel A, peak of channel B, and put them here in that table. Till this moment, this is not AB mode. Now let's go to the AB mode to see really the linear relation between the voltage of R1 and the current of R1. And this is basically very easy. Just click AB. Now we are in YT mode, as I said before in the previous video. Now, if we click the AB mode, now we are on the AB mode. Okay? Good. Now we need to measure the slope. Okay? This is a linear relation. To measure the slope, we just need one point. For example, this point here. Any point can be good. At that point, we need to know the x-axis or the x-coordinate and the y-coordinate. So again, we use the markers. We're gonna notice something bad here, is that whenever we hover, whenever we move, the reading just go away. Yeah, maybe the reason of that is because of that setting here that I didn't mention. So basically here's the oscilloscope, it has a kind of frequency in showing the signal on the screen. So we're gonna just decrease that frequency. That's what we're gonna do now. So it's currently 100 millisecond, make it 50 milliseconds. We increase it 50 seconds, I'm sorry. Now you see, guys, it become much stable now. 50 seconds. It will be just constant. So it will not change again. Okay, it will not disappear as before. Now, this is the slope, guys. If we divide this by this will give us the slope. And the slope is 1000. Can we try another point? Because if you just divide this, it will give you 1000. Can we try another point? Yes, we can try another point. For example, here again, if we divide this by this will give you 1000 again. Okay, and of course, whenever you go through the experiments, there are some requirements here in the lab manual that you should do, but I did all of them. Okay, so that's basically the first part of the first experiment. Okay, still there is another part. We start here from point 11, in which I want you to repeat the same procedure again, but after changing R2 to 1 kilo ohm. 1 kilo, not 1 ohm. So it was 1 ohm. Okay. Now we're gonna make it 1 kilo ohm. Okay. Still we want our slope to equal to 1000. So let's see what will happen if we change R2 to 1 kilo ohm. We should start first, close the current, into the current simulation, and change R2. Then we do running again. Let's see now what will be the slope. Nothing is appearing. Let's go back to YT mode. Apparently something has changed. So basically the red one is R2 now, become much bigger. So let's make it 10. Let's change it. For example, 5. If we make it 10, it will be the same. We are now overlap of each other. It doesn't disappear or something. They are just overlap on each other. So let's make it 5, for example. So it become clear now. And let's now go and make the AB mode again. Okay, that's good. Now we have the AB mode. How about the measurement, the slope now? Okay, basically now that's good, because now this marker doesn't point at the our slope. Also, we can still read, but it's good to make it, to refer to the channels, not the x-axis, which is time. Good. Now it's referring to channels. Now, if we make, for example, at that point, look, 5.019 volt and 5.019 volt. That's bad, because the slope now is 1, not 1000. Okay. And let's now ask you a question. Why is that? Why we changed this R2 to 1 kilo, the slope changed to 1000? I'll give you 5 seconds and you can also pause the video and think about it, and also think how to fix that. Okay, so let's count. 5, 4, 3, 2, 1. Okay, I hope you get it right, but let me give you the answer. So basically, in the beginning, R2 when R2 was 1, so I equal to R. Okay, and we can just take the measurement of channel B and put it in the equation, which is the slope equal to channel A reading over a channel B reading, and that's it. This will give you a slope. But now you are measuring, or you are dividing channel A voltage over a channel B voltage. But the channel B voltage now, it does not equal to the current, because now the value of the resistor is 1000, not what ohm, like the first part of the experiment. Okay, so I now equal to V of R2, which is in that case 5.019, divided by the new value of R2, which is 1000, not what ohm like here. So this will give you again 5.019 millivolt. Okay, millivolt. So if you divide now 5019 by 5.019 millivolt, this will give you 1000 again. Okay, and that's basically the trick. And that's why we choose in the first place R2 to be 1 ohm. Okay, but maybe in your lab experiment, I mean in a practical setup, 1 ohm is a very small value. This might cause the current to be very high, and that may, for example, damage something, or exceed some rating, maximum rating for some of the components that you have in your circuit. Okay, that cannot handle much high currents, and at that time you might need to put a higher value of a resistor. And in that time, you still can do the parameter sweep. This is basically a parameter sweep, but you should take care of that, conversion, because now V doesn't equal to I directly. No, I is equal to V divided by the value of R2. Okay, guys. So this is basically experiment 1 in that lab. And in the third video now, we're gonna, introduce to you the second part, I mean, the second experiment of that lab, in which we're gonna, make some, slight modification that will make our circuit much more practical, than this current setup. So in the next lab, we're gonna see one major disadvantage of that circuit and how we're gonna deal with it, so that our circuit or our parameter sweep using oscilloscope become, perfect practical for a lab setup. Okay, so thank you guys, and see you in the next video. Bye bye.